Now we want to identify some of the characteristics we see with these functions. So we want to find amplitude and period of sine and cosine. Amplitude is the a value, or the value that's in front of the function. So for each of these, we're interested in the value in front of the function. So here the amplitude is going to be 9/4. Once again, the value in front. The second one here, the amplitude is going to be 5. Remember, we care about the absolute value of the number in front. This negative just indicates that we're going to flip it around the x-axis when we graph it. And then finally, right here, the amplitude is going to be a positive 0.5. The period then, we always find the period of sine and cosine by taking 2 pi divided by b. So we're going to find the b values in each of these. And the b values are what's attached to the x. So right here, the b value is going to be 1, because that's a 1x. So my period is 2 pi over b, which is 2 pi over 1, which is just 2 pi. The second example here, the b value is 1, because there's a b attached to the x. So my period here, 2 pi over b, which is 2, is going to be just pi. The final one here, you can see it's sort of a mess. We can rewrite this with this pi over 6 in front. This can be rewritten as negative 0.5 cosine of pi over 6 times x, just moving that pi over 6 in front of the x. So my b value is pi over 6, so I'll take 2 pi over pi over 6, which really is 2 pi times 6 over pi when you take the reciprocal and multiply. Pi's cancel out, and 2 times 6 is 12. So my period ends up being 12 there. The second skill then is being able to identify how graphs change. And we want to use terms such as horizontal shrink, vertical shrink, horizontal shift, x-axis reflection, y-axis reflection. What are all the different changes that you see between two graphs? So the graphs that you would see normally are parent functions, and we want to compare between parent functions and then the shifted graph. So right here, y equals cosine of 2x. I know it's not the official parent function because it's not cosine of 2x, but we're going to compare these two. So the first thing that you see is that if we've got a 2x right here, we got 2x in both of them, comparing that to the parent function, that indicates a horizontal shrink. The b value, which is the parent function, or excuse me, the b value, which is the period, indicates a horizontal stretch or shrink. So the 2 in front is larger than 1, so it's going to shrink. The second thing we've got is we have a vertical stretch. And the reason for that is the amplitude in front. And that vertical stretch is 5-fold. The last piece that we have is this negative piece here. And that is going to be our x-axis reflection. Means we're going to flip it around the x-axis. So if we're going to compare different functions, we look at the vertical stretch, x-axis reflection, and horizontal shrink of this one. The second piece we've got, we're actually comparing the true parent function, y equals sine of x versus y equals negative 5x plus 3. The first piece that we have is we've got a vertical shift, and it's going to be 3 up. That plus 3 in the back is the d value, indicating vertical shift, and positive is up, negative is down. We've got a horizontal shrink. Because of that 5 that's in front of the x, that's the b value. And when b is greater than 1, it is going to get more compressed. And we also have a negative inside the function. And a negative inside the function indicates a y-axis reflection, just as it did if we had the negative inside of the polynomials that we talked about earlier. The last piece right here indicates a value we need to factor out. Here we've got this pi in front of the x with an additional quantity. So really here we need to factor out a pi before we do anything. So when I look at this piece compared with the top piece, we've got a horizontal shift and we've got a vertical shift. Vertical shift is going to be 4 units up, and the horizontal shift is 1 to the left. If we saw that pi in there, we would think it'd be pi to the left, but once we see that pi factor out, we can clearly see that plus 1 is really 1 to the left.